Lesson 13, Histogram, Example 2. Use the age data, question 4, from our Sierra College Elementary Statistics Student Survey to construct a frequency histogram and describe the result. In order to construct a frequency histogram, we'll construct a histogram where the vertical axis displays the frequency, or count. After we've done this, we will then use words to describe the result. So to begin, we need a title. The title needs to communicate the data, which in this case is age, along with the population from which the sample was collected. In this case, Sierra College Elementary Statistics students. So an appropriate title for this histogram would be Age of Sierra College Elementary Statistics students. Then to construct the actual histogram, we need to draw both the vertical and horizontal axes. Now we need to clearly label each axis. Starting with the horizontal axis, the data axis. In this case, the data is age, so we'll label it age. Then, the vertical axis is the statistic of interest. In this case, we are specifically asked to do a frequency histogram, so we will label it frequency. Now we need to look at the data and find out the frequency of all the various age groups. We had already done this in a previous example, so we will just use the results of the previous example to help construct the rest of our histogram. So here is the frequency distribution table that we had in a previous example. The first column, the data column, age, is displayed on the horizontal axis. So all of the decisions that went into deciding where to begin and where to end, how many rows to use in the table, and what is the scale or the increment we use when counting from group to group, are the same type of decisions that are made for the construction of a histogram. So here we decided to start counting at 15, and we use a scale of 5. So labeling along the data axis, we use the same groupings, the 15 to 19, the 20 to 24, and so on, all the way to the last group, which is the 50 to 54-year-old age range. Now on the vertical axis, the frequencies are counts, and they always begin at 0. So the labeling on the frequency axis always starts at a minimum of 0. The maximum frequency always goes up to the highest frequency, or beyond. In this case, the highest frequency was the 26 students who were in the 20 to 24-year-old age group. But if we were to list individually all the numbers from 0 to 26, the frequency axis would be too crowded and not easy to read. So we will come up with a scale to make it easier to label. Any scale that would give an appropriate listing of the data would be fine. In this case, I'll use a scale of 5. So to count from 0 and going at or beyond the 26 by counting by 5s, we would go 0, 5, 10, 15, 20, 25, 30. So now that we have the horizontal axis and vertical axes clearly labeled, we can now construct the histogram by drawing our bars. The bars need to be drawn completely surrounding the data values so that there is no confusion as to which data value belongs to which bar. And also, the height of the bar corresponds to the statistic of interest, in this case the frequency. So the first age range, the 15 to 19-year-olds, had a frequency of 9. So we will draw a bar completely surrounding the 15 to 19 age group to a height of 9 on the frequency axis. The next age group, 20 to 24-year-olds, had a frequency of 26. So we will draw a bar that surrounds the 20 to 24-year-old age range to a height of a frequency of 26. Also, in histograms, the bars are drawn touching each other. So we make sure that occurs. Next, drawing a bar touching that bar, we make it so it totally surrounds the 25 to 29-year-old age group, and its frequency was 4, so it gets drawn to a height of 4 on the frequency scale. The next age group, 30 to 34-year-olds, there was only one student there, so the rectangle drawn surrounding the 30 to 34 age group only goes to a height of 1. Same thing for the 35 to 39-year-old age group. We draw a bar totally surrounding the 35 to 39-year-old age groups up to a height of frequency of 1. There were 2 students that were in the age group 40 to 44-year-old in the sample. So we draw the bar surrounding the 40 to 44 age group to a height of 2 on the frequency scale. In the 45 to 49 age bracket, there were no students in that group, so no bar is drawn in that interval. And finally, the 50 to 54-year-old age group, the frequency was 1, so we draw a bar surrounding the 50 to 54 age range to a height of 1. So here is our completed histogram for the age of Sierra College elementary statistics student data in our survey. Now we're ready to describe the results. Since the age data is quantitative data at the ratio level, age data follows an order. So we can use our special terms to describe the overall pattern in the data, as opposed to just describing each section along with a corresponding statistic. In this case, you'll notice that the highest frequency, or the most common age range, was in the 20 to 24-year-old age group. And the ages that are younger than that do not extend very far. But the ages that are higher than that do extend very far. So this is an asymmetric distribution, or skewed. And since the older age groups extend much further in the increasing or positive direction than the younger age groups do extend in the negative or decreasing direction, this distribution is referred to as positively skewed. So we can give the following description. The age of Sierra College elementary statistics students has a positively skewed shape distribution. Now, realizing that the distribution of the data is skewed can provide some insight into important aspects of the data. For instance, skewed distributions could be an indication of the presence or absence of various constraints or restrictions on potential data values. If the data values do not extend very far in one direction, it may be due to the presence of a nearby limiting factor. If the data values do extend very far in one direction, it may be due to either the non-existence of any limiting factor or the limiting factor being far away from the data. In this sample, the age of Sierra College elementary statistics students did not extend very far in the younger direction. That is probably due to the fact that students need to progress through several years of education before they are sufficiently prepared to enroll in an elementary statistics course at Sierra College. On the other hand, the age of Sierra College elementary statistics students did extend far in the older direction. This is because there is no upper restriction on age as to when a student can enroll in an elementary statistics course at Sierra College. As long as the student is prepared to take the course, it is never too late to learn.